Section C3, or kinematics. So in this kinematics problem, we're going to do what I call the window problem. Now the window problem's tricky. I remember seeing this problem many years ago when I first started teaching, and I found it a little bit sneaky. What we're going to do is construct the problem so we can understand it thoroughly and then pose the problem similar to the way I first encountered it. So what we're going to do here in construction, and constructing physics problems is a good way to learn physics and to reinforce our concepts. What we're going to do is fire a ball upward from the ground at 40 meters per second. The ball is then going to momentarily stop. The velocity will be 0 at some point at the top, and then it's going to fall down again and reverse things. So if this situation occurs, to find the velocities first, let's make a little table. The velocity is the initial velocity plus a t. Now, in this case, I'm going to pick up to be positive, and that means I'm going to have a minus g for the acceleration, because the g, it's going to point down. The gravity's going to pull you back to Earth. And then we're going to here, have that 40 is going to be this one here. And then what we're going to do is make the math very, very simple and take the 9.8 meters per second squared and use 10. I don't want the arithmetic to distract us. So this will help us with the numbers. And then we're going to make a little table here where we have the t in seconds and the velocity in meters per second. And we're going to go here, say 0 seconds, 1 second, 2 seconds, 3 seconds, and 4. When you put in 0, well, let's write that equation out. Like, what is that equation? That's going to be V is 40 minus 10t. So when t is 0, you have 40. Then when t is 1, 40 minus 10 is 30. When t is 2, 40 minus 20 is 20. When t is 3, 40 minus 30 is 10. And when t is 4, 40 minus 40 is 0. So that's where it's going to momentarily come to rest, and then it's going to fall down. Now I would like to also have like how high it is, and we'll call that the y. In other words, what is the y as a function of time? So our y equation would be, if we start with basics, y naught plus v naught t plus at squared. Since up is positive, I'm going to start, though, from the ground, so this one's going to be 0. This is going to be 40. And then the a is going to be a negative 10. So y, as a function of time, is going to be 40t minus 5t squared. So if you put in t is 0, you get 0 minus 0. This is 0. If you put t as 1, you have 40 minus 5. So that's 35. If you put t as 2, 2 times 2 is 4. 5 times 4 is 20. You subtract, well, let's go ahead and do this one since the math's getting a little more involved. So this is going to be 40 times 2 minus 5 times 2 squared. So that's 80 minus 20. And that's going to be 60. So therefore I come up here and put 60. Then for the third case, I'm gonna have 40 times 3 minus 5 times 3 squared. So this is 120 minus 5 times 9, which is 45. So when I subtract there, it will be 75. And then for the last one here, I'll have 40 times 4 minus 5 times 4 squared. So this is 160 minus, well, 4 squared is 16, 5 16s would be 80. So when you subtract the 80 from the 160, you get 80. So this is our complete knowledge of what's going on. We're going to construct the problem now, and now here comes the fun. Okay, so we have here 0 meters, and we're not going to tell much information to the person doing the problem. We're going to have a window up here, but between you and me, we're going to know what these values are. We're going to know this is a 60 meters, and we're going to make the window 15 meters. And we're going to know that this is 60 meters above the ground, but we're not going to tell that to the person doing the problem. So this would be then 75 meters. Now they're not going to know these red ones. And we know that we're going to go up to 80. The ball is going to go up to 80. So we know that there's going to be 5 meters here. We're going to tell them that when you go this 15 meters, we're going to go 1 second. So we're going to say that this takes 1 second. So we're going to give them that. And we'll also give them that the ball goes off the ground at 40 meters per second. All right, so this is kind of strange information we're giving them. We're saying that there's a window, big window, and we're looking out the window, and in 1 second, we see the ball go past the window. And like that's it. And then we're going to ask them to figure stuff out. All right, well, what should we ask? We're going to ask, the first question is, we're going to ask, what is the distance above the window that the ball goes? All right, so how far above window does the ball go? That's going to be one question. And then we're going to ask, how far above ground is the window bottom? So I'm basically going to ask for this distance. I'm going to ask them to figure this distance out. And then I'm going to ask them to figure out this distance. So these are the questions, like what is this? What is the distance from the bottom of the window to the ground? And what is the distance above the window that the ball goes? This looks like there's not enough information. Like we're not telling them how high the window is. So here's what we're going to do. Don't worry. What do we know? Well, we know time and we know distance. So we could use this formula where now this velocity sub-zero for this problem is going to be the velocity at the bottom of the window. Now see, this is what happens. We change, what D and V naught means because we're doing different subsections of the problem. So for this little segment of the problem, I'm going to call this the initial speed here. And A is going to be, again, minus 10. that was given in a problem to do that. So if we work that out, and we know that this is 15 meters, we know that, and we know that t is 1 second. So t is 1 second. So that gets us the equation 15 is equal to the unknown v naught times 1 minus 5 times 1 second squared. All right, well, this is easy. V naught is equal to 20 meters per second. So I know that at this point, the ball is traveling at 20 meters per second. Now, if I check that with my chart, at 60 meters, the velocity is 20 meters per second. That's correct. However, the person doing the problem doesn't know it's 2 seconds and doesn't know that it's 60 meters above the ground. But look, this was figured out. We figured out the 20 here. Now, the way I approach this problem is I try to find out something that I can do. I couldn't find how high the ball went unless I had some information like the velocity at the bottom of the window. If I knew that, now I can find how much time it takes the ball to stop. So here, I went to this equation because I knew the d was 15. I knew that the time was 1 second, knew the acceleration, and I could find the velocity at the ball here at the bottom of the window. So I got to start somewhere. So that was my approach. But remember, there's 4 equations, a lot of stuff. You can take different approaches, but it's the approach that I took. And don't worry if you take an approach and get a dead end and you got to start over again. Like, in other words, use an equation and find out you don't have enough stuff. So this gives me that V naught there. And now to find out how high that's going to go, I have a new problem. I have a new problem where I have, say, a V naught is 20 meters per second, and a V final is going to be 0. And this distance I don't know. So that's 2AD, when I have my 2 velocities, that's what I like to use, is 2AD1. So here I have A is minus 10, so this is minus 20 times D. Now I'm trying to find out how high it goes above the window. So remember, the window is your 15 here meters. But we're going to find out the D. This is going to be the D for this next problem. So that's going to be, the final velocity is 0, and the velocity down at the bottom is your 20, is your 20. So this is minus 20 times D equals minus 400 when you square the 20. So D is 400, the minus signs cancel, over 20, 0 cancels, and I get 20. Now that means it's going to go 5 feet above the window. But see, by the construction of the problem, we already knew that. But now we figured it out. We still don't know it's 80 meters high, but we do know we got the 5. We answered the second question, which is 5 meters, or that's the first question actually. It took me 2 steps to get there. That's question 1, 5 meters. Now to find out, this one's going to be straightforward because if I know 20 meters per second here and I know 40 down there, I have my velocities. So 2AD is V squared minus V naught squared, and here once again the variables represent different numbers because, see, now the initial one's going to be the 40 and the final one is going to be the 20. So we're going to have here 2 times minus 10 times D is going to be 20 squared minus 40 squared. This here is the initial one. The final one is the 20. And the D now is this distance. I mean, the other alternative, if you don't like this approach is to put subscripts like crazy all over the place. I find that more confusing. I'd rather do a new problem with the simple formula as we go and then give my answers, box the answers off. I mean, this is the answer to the first question, and this will be the answer to the second one. So minus 20D is 400 minus 1600. This is minus 20D is minus 1200. So the minus signs are going to cancel, and I'll have D is 1200 over 20. That 0 goes, and I get 60. So this D is 60. To the bottom of the window, it's 60. And that makes sense because 60 plus the 15, 75, plus the 5 is the 80. So, like, we got it. So remember that the person doing the problem didn't know all this information, but it's checking out with our table. So I think this is an excellent problem, the window problem, where we pose it with the time to go from the bottom to the top of the window and not say how far the window is above the ground and how far the ball's going to go. It's really a great problem. So I hope that you enjoy that one and learn some subtleties.